the universe is the way it is because some intelligent force designed it to be that way. And so for me, when I was looking at all of this stuff coming out of my atheism and just saying, whoa, really, this is the best explanation. And because I was raised with zero religion, and so I arrived at all of this with the minimum amount of baggage. And so to me, it was just like, of course, some kind of transcendent intelligence makes the most sense.
ID, the Future, a podcast about evolution and intelligent design.
Well, welcome to ID the Future. I'm your host, Andrew McDermott. Thank you for joining us today. Well, on the show today, we have astrophysicist Sarah Salviander, one of the experts featured in the new movie, The Story of Everything. The movie, which opens April 30th, 2026 in theaters, is a cinematic exploration of the cosmos that traces the evidence for intelligent design from the precise laws that govern the stars all the way down to the intricate structures found in every living cell. It is quite an adventure, and it's going to be available very soon, so I hope you can join in and see the movie wherever you might be. Now, Sarah is a former researcher in the Department of Astronomy at the University of Texas. She studies extreme deep space phenomena, mostly quasars, supermassive black holes, and giant galaxies. She has authored peer-reviewed journal and conference papers, as well as popular-level magazine articles. She also regularly brightens social media feeds as a science educator. And who doesn't need a brighter social media feed these days? Sarah, welcome to the podcast.
Hi, thank you.
Yeah, and it's actually your first time, so a hearty welcome to ID the Future. I hope the first of many conversations sharing some of your expertise as an astrophysicist. Now, for those who haven't seen the trailer to The Story of Everything, I'm going to start there. We're going to share a 60-second trailer to the movie just to whet your appetite. Here's that now.
Today, I'm going to tell you a story which may seem very strange to you.
How in the world did this start?
Has the universe always been here, or is it finite?
We want to take our metaphysical hypotheses and see what they point to.
Here is evidence for what can only be described as a supernatural event.
Turned out to be the tip of the iceberg. Without guidance, we would get a life-unfriendly universe.
We're dealing with a system of manifold, complex design.
We associate information with a rational intelligence behind it.
The universe, it bears everywhere the fingerprints of its creator.
The concept of life as a cosmic phenomenon should have many consequences. The question then was, what does one do about it?
Now, Sarah, welcome again. I know it's your first time here, and, some audiences might be less familiar with your work, so let's just jump into a little bit of background. You were a lifelong atheist, raised in a secular home and deeply influenced by science fiction, as well as Mr. Carl Sagan, yet you became a Christian through your scientific work. So what was the pivotal moment, if there indeed was a single one, maybe it was a long line of them, in your astrophysics work that first made you question your atheism?
Well, I first began to question my atheism as an undergraduate. I was a physics student and thought, well, I had better understand, why I believe the things that I believe, and started looking at the big questions. Where did everything come from? Where do we get our basis for morality and things like that? And realizing that it was no easy task to arrive at the things I believed in just kind of from first principles, just from like the brute fact that the universe exists. And that really troubled me. I was really upset that I couldn't, for instance, arrive at sort of conventional morality just from the fact that the universe is here and we're here. And I just sort of tabled that, just like, yikes, I don't like where this is going. So I kind of just left it. And then I got offered a research internship at UC San Diego in the Center for Astrophysics and Space Sciences. It was just a wonderful experience. And they assigned me to a cosmology group studying chemical abundances in the early universe. And so it was as I was studying this, and we were using quasars. Quasars are supermassive black holes that are actively feeding on material, and they're become super energized, super luminous. You can see them from billions of light years away, and they provide the background light bulbs to see the chemistry of the early universe. And I remember, I'm working on this research project, and I'm walking across this beautiful La Jolla campus and thinking about all of it. And I remember just literally stopping dead in my tracks and thinking, the sheer amount of, it just seemed to me like design, like purpose in arranging the universe in a way that, we can answer these questions that we have, these big, big questions about the universe. We're just these little biological specks on a little hunk of rock, in space. And yet we can ask and answer huge questions about the universe, like what happened shortly after the universe was born. And I just thought everything that needed to be in place in order for us to explore this question, it just seemed to me that it was just a little too designed, a little too on purpose. And I remember in that moment when I stopped in my tracks, I thought, God, some kind of transcendent, purposeful, intelligent force was what made the most sense. That whoever this was inviting us to explore his creation. And so I became a theist on the spot. And I remember also at the same time thinking, well, this certainly solves the problem of where our sense of morality comes from too. So it was two birds with one stone, and I was pretty happy about that.
Wow. Yeah, I think it was Carl Sagan that compared us to mites on a plum. But what he forgets is that these mites have a great view of the universe, have figured out how to study it, and find that it's intelligible and that it makes sense,
Yes.
and that it's beautiful and purposeful. Those are things he forgets to mention about us mites here. Now, you mentioned Carl Sagan as an influence. Did you read his work? Were you was he the reason you guys were atheist, or was it just sort of a given in your household?
It was just a given. It was just, how my brother and I were raised. My parents were both ex-Catholics. They were socialists. They were politically active. And this is why we moved from Oregon to Canada, because my parents wanted to be in a more secular socialist environment. And so that's where my brother and I grew up. And so that was just our environment. And it's kind of like William Lane Craig says, he calls cosmology a religion for atheists. And he's not saying it in a mocking way. And it was for me because, even as a kid, I needed a sense of, where's our place in the grander scheme of things, and just wanting to feel a sense of awe and wonder about the universe. And so Carl Sagan was wonderful at imbuing that. So I watched his show Cosmos, because I was a kid of the 70s and 80s. And so I grew up watching PBS and watching that show and just thinking, the universe is such an amazing place. Science is it just felt like home to me. It gave me that sense of perspective and belonging and awe and wonder that I really longed for.
I just want to ask you about that evidence a little bit more. Was it deuterium? Is that how you say it? Deuterium abundances?
Deuterium, yeah.
Okay, now tell us more about how, what is that and why it was such a powerful indicator.
Okay, yeah. I hope this doesn't get too technical for people here. So deuterium is an isotope of hydrogen. So hydrogen is just a proton. And if you tack a neutron in there, you get heavy hydrogen, which is we call deuterium. And so in the very early universe, you have in the first few minutes right after the Big Bang, you get Big Bang nucleosynthesis. So this is the universe is so dense and hot that you're literally getting the whole universe is a fusion factory and fusing things together. And so you get things like, of course, you've got hydrogen, and then you get deuterium, you get helium and lithium, you get the very lightest elements. And the Big Bang Theory makes very specific predictions about what ratios those light elements are going to be in. And so, of course, even though we kind of accept the Big Bang is pretty much the dominant model of cosmology, you always need to be testing these things. So the group I was working with was testing how much deuterium is actually in the universe relative to just plain old hydrogen. because this is a very sensitive test of the Big Bang model. And it turned out that we confirmed the model, that the deuterium abundances were pretty much right on the money when what you would expect if the universe was born from a highly energetic Big Bang kind of situation. And I just thought that was so exciting, that we could investigate this and that the data confirmed it.
Hmm. Wow. Yeah, that is great. And we'll mention a bit more of the different evidence that has been found to confirm the Big Bang shortly here. Now, how did the Story of Everything movie come across your radar? And can you describe the experience of being interviewed for the film? What did you think of the sets when you walked in?
Oh, I love the set. So, it's the first time being on any kind of a set. What's kind of funny is that my husband, who's from Finland, his mother was a famous stage and film actress in Europe. And so he grew up on sets. He grew up in the theater. And so for him, this was just like, oh, very familiar. For me, it was just like, I don't know. It was just like, this is really neat. I'm sitting in this really nifty looking kind of living room thing, but there's people all around and the cameras and everything. And then off you go with the conversation. I
Yeah.
don't remember how it came across my radar. I think somebody contacted me and told me about it and asked me if I wanted to be involved. I was like, of course. And what made it a little easier is that at the time I had family living in Seattle. So it was
Oh,
just
okay.
kind of a natural fit to go up and visit them and stay with them and then participate in this. So yeah, it was a great experience.
Yeah. And it's been several years in the making, so I'm not surprised
Yes,
you can't remember the specifics. I get
right.
that when I'm talking to some of the experts, but that is sort of the way of it. You get an interview recorded and in a can, and then it takes a while to really come out into something. But here it is. It's upon us. It's what, 7, 8 years in the making. Really, I remember some of the first conversations about it. How can we take the arguments that are in Stephen Meyer's book and make it accessible to an audience cinematically. But in any case, it's here and it's pretty awesome. Have you had a chance to see the whole thing yet?
No, I wanted to wait. I just
Oh,
really
okay.
wanted to wait.
Okay.
I'd seen the trailers. The trailers look incredible. And it's
Hmm.
funny like that because I'm super into movies. And so I read a lot of books about written by actors and directors and producers about what the whole experience is like. And they say that a lot of times, especially for the actors, you don't know what it's going to turn out to be like. So you're just as surprised as the audience sometimes. And so when looking at the trailers, just like, this really looks magnificent. I got excited for it all over again.
You'll have a chance to go see it on the big
Yeah.
screen?
Yeah, I'll go with
Okay.
my family. Looking forward to
That's
it.
great. Yeah. Yeah, you're right about that. It's I sometimes wonder what those famous actors feel as they see the whole thing, put together. Quite a special feeling.
Mhm.
And you'll get some of that for sure. Now, the first part of the movie tracks the discovery that the universe had a beginning. American astronomer Vesto Slipher provided the first strong evidence that the universe is dynamic, not static. That was sort of the first step was, okay, is this static and eternal or is it dynamic? The first step to identifying a beginning. So I'm going to play a clip here from the movie where you're describing the data that Slipher was observing. Let's watch that together.
The light coming from these nebulae is shifted in the red direction of the electromagnetic spectrum. You shine light through a prism, it will separate into the different colors, red to violet. The red light corresponds to light with longer wavelengths.
We call it redshift because light that has a longer wavelength tends to be more red in color. Let's say that you've got a fire truck going past you with its siren on. And as it goes past, the pitch changes. So as something is moving away from you, whatever kind of waves it's emitting, whether it's sound waves or light waves, are going to be stretched out. So since the nebula that Slipher observed was shifted in the red direction, it meant that the nebula was moving away from us.
Now, a nebula at the time was thought to be just a gas cloud within our galaxy.
So what did Slipher discover about the light coming from distant galaxies and why was it important?
So you have to understand at this time, they didn't know that what they were looking at were galaxies yet. There was a big debate at the time, these little spiral nebula-looking things, Were they small objects within the Milky Way, or were they humongous objects at great distances, galaxies unto themselves? So I think it was Lowell who had Vesto Slipher looking at these spiral nebulae, taking spectra for them. And what he noticed, and it was a painstaking, very long process for him to take this data, but he noticed that either all of them or almost all of them were the spectra were redshifted, meaning that if you take all of the spectral lines that you would observe for the different elements in these objects, that they were all shifted a bit to the red. Now, they understood in terms of Doppler that redshift and blueshift meant either something's moving away from you or towards you. But why would all of these objects show a redshift and be moving away from us? And it was really perplexing because they didn't have an explanation for this. You just might naively expect that you would get an even mix of red and blue shift, but that's not what he saw. And so later, once you get Georges Lemaitre, who's the one that solved Einstein's general relativity equations to show that the universe is expanding, and then you get data from Hubble and Humason showing that the redshift of galaxy spectra correlates with distance, that you kind of put it all together. You go, oh, the universe is expanding. That's why this is happening. These are galaxies, distant galaxies, and everything is rushing away from everything else. And this really only can be explained if the universe is expanding and had a beginning to that expansion.
Right. And in the same segment of the movie, you and Steve Meyer talk about what happens if we start to wind the clock of the universe back. You get to the beginning of the expansion, but also the beginning of the universe. Here's that moment in the film.
But what do you do when you mentally run that scenario in reverse?
As we begin to wind that clock backwards and think of what the universe would have been like 1,000 years ago, or 1,000,000 years ago, or 1,000,000,000 years ago, or however far back you go, eventually you're going to get to a place where all of that expanding material would have congealed in the same place, marking the beginning of the expansion. And arguably the beginning of the universe itself.
And then you go on to describe black holes in the story of everything. You say they're extremely massive, but compressed down into an unimaginably small space. Now, I don't know much about black holes. How can it be both? And how did black hole physics point Stephen Hawking to this space-time singularity that he began to identify?
Okay, so in terms of being both massive and compact, this was something that early modern physicists really struggled with. There's a wonderful book by Kip Thorne called Black Holes and Time Warps that talks about this. And, most people, it kind of defies common sense. It defies imagination that you can have something, several times the mass of a sun, and then it's compacted down to something that's just a few kilometers across. This is what the math predicts. And this is what we observe. Astoundingly, we do observe evidence confirming these mathematical theories. And it's just, I don't think it's really possible for people to try to make it a common sense, kind of intuitive understanding. I think you just have to accept how strange it is. And, if anybody struggles with that, you're in good company. There were physicists along the way who just said, no, don't like this. This is just too strange. Now, as far as Stephen Hawking, when you use the word singularity, it's a word that's used in particular ways by physicists. And one way, so singularity, people think, okay, this means a point of infinite density. So any amount of mass, if you compress it down to basically zero dimension, you're going to get something of infinite density. But what physicists really mean is this is where the known laws of physics break down. And so it's just a big question mark at that spot. And so you can also talk about the universe beginning as a singularity. And what physicists try to get people away from is thinking that the universe must have been like a single point. And really what it means is, regardless of how big the universe might have been, it was pretty much, like you're approaching infinite density, and you're also at a point where the known laws of physics just utterly break down.
Hmm. Okay, so this is what Stephen Hawking was wrestling with. Now, at what point did they realize, yes, we have evidence of a beginning to the universe?
Well, so that was back in the 1920s. Beginning with Lemaitre, who he had this model of what he called the primeval atom. So just like, if you rewind the equations, if you rewind the data, you do get to a point where you get kind of a singularity, and you get a very strongly implied beginning. So they were aware of this, in the 1920s with the math and with the data. And it was unsettling because you have to remember that since the time of Aristotle, people believed the universe was probably eternal, at least, from a philosophical, natural scientific perspective. And so now suddenly we have evidence that that probably wasn't the case. And then by the 1950s, it really started to kind of heat up. And then you had astronomers and physicists who really didn't like the idea of a universe with a beginning. So they came up with a competing idea called the steady state model of the universe. And so the early Big Bang universe, and although they weren't really calling it that yet, and the steady state model were competing with each other. And then you start getting more and more data that just, annihilate the steady state model and really are in favor of the Big Bang. And physicists just grudgingly have to accept that this is the best explanation.
Yeah. Well, and indeed they did, and the movie does tell that story very well. Now, let's also talk about fine-tuning. I know that you love that class of evidence. You actually recently published a post on your Substack, Schrodinger's Poodle, great title, that briefly reviews why the evidence for the fine-tuning of the universe is so powerful and convincing. And I thought it would make a great review just to touch on a few of the points right here. Now, first, you mentioned the work of astrophysicist Luke Barnes, co-author of A Fortunate Universe, who identifies 31, count them, 31 fundamental constants and initial conditions involved in the standard models of particle physics and cosmology. And these are, you say, like dials on a universe-generating machine. That is a common analogy. Stephen Meyer uses it too. And the movie actually builds one, doesn't it? It's got that animation in there of all these dials, and each one is set precisely to permit complex chemistry, stars, planets, and of course, life. Now, with your permission, let's just discuss a few striking examples. The cosmological constant. Tell us what that is and why things would be a lot different if that value were different.
Well, that's a really powerful one, and it's a very strange case for fine-tuning. So the cosmological constant, you can think of it different ways. Sort of the energy density of empty space. That's how quantum field theory describes it. But in cosmology, we just kind of call it dark energy. And so it's just the energy of empty space. And it is highly, highly fine-tuned as far as we can tell. So quantum field theory makes a kind of not a very precise prediction of what it should be. It's kind of a range. But what I can tell you is that it makes a prediction that is absolutely enormous. Like 10 to the power of 120 is kind of the upper end of that prediction. And the problem is that what we observe is very, very, very small. So the actual measured value of the cosmological constant is quite small, which means that to balance things out, this dark energy has to be so finely tuned to cancel out this energy of empty space that is predicted from quantum field theory, that to bring it to very nearly zero. And the problem is that physicists do not like coincidences like that. We don't like to say, well, great, that worked out. We look at very, very precise balancing like that and go, why is this the way it is? And so this would be an example of extreme fine tuning Now, the problem, like, so people say, okay, well, why does this matter? Because if the cosmological constant was very different from what it is now, you would not have life in the universe as we know it. So the problem is that if you have too much cosmological constant, the universe expands before you can even get any structure forming, before you can get stars and galaxies forming. Okay. And then if it's too little, well, then the universe just collapses before anything, like life can form. So that's a pretty extreme example of fine tuning.
Yeah. Just one parameter balanced on a razor's edge. What about gravity? That's something we're familiar with here on Earth. How does gravity affect the universe, and what would happen if that value were different?
So yeah, we're all familiar with gravity. That's why we don't go flying off the surface of the Earth into space. So now, one curious thing about gravity is that it is extremely weak compared to the other fundamental forces. And so, this invites a lot of speculation. Why is gravity so weak? But it has to be that way, or we would not have the structure that we have. And I always I have to consult my notes to get these numbers because I never remember these.
Oh, yeah.
So
Hard to remember.
yeah, so it's like when I teach physics, and I tell my students I don't have all of these constants and equations memorized, so I don't expect you guys to either. I let them have a cheat sheet, so I have a cheat sheet. And so the strength of gravity is 10 to the 40th power times weaker than the electromagnetic force. Now that's crazy. That's just huge. But that's important because if it was slightly stronger relative to the electromagnetic force or the nuclear forces, the problem is that you would get stars forming too quickly. So they would form very quickly. They would burn out very quickly. They would progress to black holes way before you could have life getting a chance to form. So that's a problem. Now, if it were weaker, then matter just wouldn't clump together in the structures that we see that are necessary for life to appear in the universe.
Okay. And you also, in your post, mentioned electromagnetic and nuclear forces. How do those play into it?
Okay. Yeah. So the electromagnetic force is a really important force, especially for astronomy, because this is basically what produces light. The light that we observe, and also governs chemistry. Now, with regard to the strong, this also ties into the strong and weak nuclear forces, and these are the forces that hold nuclei together in atoms, that govern the rules of fusion and fission and things like that. So in terms of, like, if you have a strong nuclear force, so this is the force that causes protons to stick together. But if anybody remembers from their high school science classes, that like charges repel. So they don't want to be together. Two protons, two plus charges are going to repel each other. So that is the electromagnetic force that causes that repulsion. But you need protons to stick together in order to get heavier elements and the elements necessary for life. So in order to do that, at some point you have to overcome that repulsion, and then the strong nuclear force takes over and glues those protons together very strongly. And it is that balance between the strength of the electromagnetic force and the strong nuclear force. If that was off at all, you would either get, you would not get heavier elements forming at all, or the problem is that you would get, like, for instance, nearly all hydrogen in the early universe would have just immediately fused to helium. Well, without hydrogen, you don't have things like organic molecules, you don't have water. And so life as we know it would not have a chance to exist.
Well, and that's just 3 or 4 that we've mentioned out of 31 parameters that are all balanced on a razor's edge. And, then the next question is, well, why? And as you say, cosmologists don't like coincidences. And so we'll mention the multiverse in a moment. But there's one point that you make in your post that I wanted to reiterate, and that is that you point out that slight tweaks to these parameters wouldn't just result in exotic universes teeming with other forms of life, things we can only imagine. No, what would we actually see in universes with even slightly different fundamental values? What would it actually look like?
So yeah, and this is a point that Luke Barnes makes, and I really encourage people to read his articles and his books. What he talks about is that yeah, so this was response you get from atheists who kind of dismiss fine tuning. You say, well, you could just maybe you'd get entirely different forms of life, but as Barnes points out, what kind of life could you even conceivably get in a universe that's just filled with a thin soup of hydrogen particles? I mean, that this is something that you would end up with, or a universe that's just full of black holes. So, yeah, there's not really an opportunity for exotic life that in any way we could imagine because you're not getting any chemistry forming. You're not getting like, silicon-based life form. Like some people like to speculate about that. You're just getting a universe with just protons or with just black holes. And no kind of life that we can think of would exist like that.
Well, and there's three things that would explain the fine tuning, and that's chance, necessity, and design. Those are the three, ways that we've identified. Now, why are chance and necessity not adequate explanations?
So necessity first. So necessity would say that, when you come up with these models and these theories like the standard model of particle physics, which is really important for cosmology, there's nothing in those models and the theories and the equations that says you have to have these values for these constants. In fact, it's the opposite. We measure the values of these parameters and we try to measure them as accurately as we can. These are what Barnes calls free parameters. They can be within the confines of our theories. They could be anything that's in a very, very wide range of values. So necessity, we just don't see any evidence that within these models, these physical models, that these parameters have to be the values that they are. Now, chance is just that, well, we just won the universe lottery. We just happened to get a universe with these 31, possibly more parameters that are tuned exactly how they need to be to give rise to life. So, and they're so absurdly fine-tuned that I don't know of any serious scientist who says, yep, it was just chance. There's one universe and we just got lucky and got the exact right one. So when you rule those two out, you're left with just the third possibility. And however, unsettling some people might find that, that's really, the best explanation. Of course, as I think you want to talk about this soon. Some people deal with this by invoking the multiverse.
Right. Yeah. And that was going to be my next question. But the whole chance thing, you could understand maybe one or two or three of these parameters maybe, happening to be a certain value. But when you're lining all of them up and you're saying that's chance, that beggars belief, Now, the multiverse, we've heard that word bandied about a lot in recent years, but just very briefly, what's wrong with the multiverse hypothesis?
Well, it's completely speculative for one thing. I don't know of any serious way to test the multiverse. So
Hmm.
there's a problem is that you can come up with, interesting ideas. You can even come up with mathematical models that are internally consistent. But the problem is to see if they actually describe reality, you have to be able to test them. And I don't know of any way to test something that is literally outside of the universe. So that's a huge problem. But also, William Lane Craig is a great resource for this, and just talking about the absurdities that come with the idea of the multiverse, particularly with, effectively, you're talking about some kind of unknown mechanism that generates effectively, an infinite number of universes, or just such a huge, inconceivably huge number of universes. So first of all, what generates these universes? How? But then you've got all the problems that come with infinity, just the philosophical absurdities that come with that. And so then you've got the question of, okay, you know, what generated the thing that's generating all these universes? And you kind of end up with the turtles all the way down problem where you're just kicking the can. Um, you're not arriving at any kind of ultimate explanation for reality. And that's just philosophically really unsatisfying.
Yeah, yeah. Makes it a very imaginative idea, And of course, sci-fi, comic book writers and movie makers, they have a field day with it
Oh, they
because
do,
it
but,
makes for great storylines.
sometimes, but I've actually come to hate the multiverse in science fiction because it actually just kind of destroys the tension and the stakes because it's like, well, this character just got killed, but there's an infinite number of this same character in other universes, and we'll just keep
Yeah.
revisiting this because, we want to bring this character back, and it's just like, oh, it just nothing has any tension or, it's just like, okay, they'll just
Yeah.
bring this character back,
It lowers the stakes for
it
sure.
does.
Yeah. Well, what about the tried and true objection to fine tuning that you've heard quite a bit, actually? You mentioned it in your post, and it goes like this. Well, of course it's finely tuned. If it wasn't, we wouldn't be here to observe it. How do you respond to that?
I love that. I mean, do people really stop and think about what they're saying when they say that? It's a truism. It's not an explanation. And again, Craig, he's got a great response to this, which is the firing squad
Oh,
analogy,
yeah.
which is you imagine, you know, for whatever reason, you're lined up in front of a firing squad. Maybe, you've got dozens of skilled shooters with rifles standing right in front of you, all with loaded weapons, and they all fire simultaneously at your heart. And you open your eyes and you're still alive. And so, this truism would say, well, what's the explanation? Well, the explanation is that if they hadn't missed, you wouldn't be here to notice it. It's like, but that doesn't explain anything. How did they miss? Like what happened? Was it deliberate? And so it just that's why that it's not an explanation. It's just a truism.
Yeah. Does nothing to explain the fine tuning itself.
Yeah.
Now, the third possible explanation for all the fine tuning evidence is, of course, design, right? Purpose, intelligent design. You've called the fine tuning data a cosmic signpost. Why is the design explanation so satisfactory for you?
Well, so you eliminate a lot of problems. Mainly, you've got an eternal, self-existing explanation for why things exist. So there's no kicking the can, there's no infinite regress. And so I really, in terms of just a philosophically satisfying explanation, that really does it for me there. But in terms of, the intentionality, so these things are the way they are because someone designed them to be that way. It really eliminates, the whole chance thing. The universe is the way it is because some intelligent force designed it to be that way. And so for me, when I was looking at all of this stuff coming out of my atheism and just saying, whoa, really, this is the best explanation. And because I was raised with zero religion, like honestly, as a child, I did not know who Jesus Christ was other than he was a baby at Christmas. That's literally all I knew. I didn't know anything about religion at all. And so I arrived at all of this with the minimum amount of baggage. And so to me, it was just like, of course, some kind of transcendent intelligence makes the most sense. And I didn't even worry about which religious tradition this God would belong to for years. I was just like, there's just God. And there's a really interesting quote by a Nobel laureate named George Thomson, and he's the one who figured out some properties of electrons. And so this was in the debate about whether the universe had a beginning or not. And he said that virtually every physicist would have just immediately accepted that the universe had a beginning if the Bible hadn't already mentioned it and made the idea seem old-fashioned. So what he's saying there is that there was already so much religious baggage attached to the idea that physicists had to kind of go out of their way to reject the most obvious explanation. And I feel like the same thing is happening with God, that if you could somehow imagine a world where we didn't have religious differences or people didn't have all this religious emotional baggage, that if the Bible hadn't mentioned God, I think that most physicists honestly would accept this as the most rational, satisfactory explanation for why the universe looks designed.
Yeah, that's a compelling point. Yeah. And I do think you're right on that score. Well, you have a devotional coming out later this year, and you're also working on another book that dives into the science of Genesis 1. What can you tell us about those projects?
Okay, yeah. So I had been writing apologetics works for a long, long time and always progressing towards writing an apologetics books, the best scientific arguments for God. And just a combination of a lot of things, a lot of stresses over the last several years. And I got to a point where I was just completely burned out with all of that. But I was still very passionate about science and God. And instead, I decided I just to pivot to something that was just more, you know, kind of, I hate to use this word, but kind of emotional. And just somebody had given me as a gift this really beautiful devotional where it was the author was also a watercolor artist and had done these beautiful paintings that were throughout the devotional really complemented the entries. And I thought, well, could I do something like that only with God's artwork, this beautiful, beautiful universe, all these wonderful uh, NASA images that we have of God's handiwork, and juxtapose those with these devotional entries and just what we can learn about the God of the Bible, what we can learn about ourselves in relation, and to put that together with these beautiful, beautiful images. And so that idea was born, and I found a publisher who was excited about it. So yeah, I finished the manuscript. It's being worked on, and it will come out in November of this year.
Okay,
Yeah, so
that's
that's
great.
one book. And then just the process of doing that, I was able to get through that burnout, and I'm now really passionately back into the scientific, like the really rigorous arguments for God. And so now I'm doing a deep dive into the science of Genesis 1, which is really what brought me uh, to the God of the Bible in the first place when I was coming out of
Mm,
my atheism.
okay. Yeah, that's compelling, and I'm looking forward to seeing that once it's complete. And of course, I think this is a great time to be having the story of everything coming out. People are exploring spiritual questions and answers. They're thinking about the big questions, and of course, with Artemis 2 and the mission, that we just witnessed, we're seeing how far we can go as human beings and envisioning what's out there. Um, and I know you enjoyed the movie that just came out, Project Hail Mary, which
Mhm.
explores other life in the universe. But all of it comes back to why is our universe intelligently designed? Why does it appear finely tuned for life? How do we explain that? And so I think it's a great time to have resources such as yours coming out to touch on that. Well, final question for you today. If someone were to watch the story of everything and their curiosity for intelligent design is piqued, where would you recommend they turn next?
Oh boy, I mean, there's so much out there. Of course, Discovery Institute has a ton of materials, and every time, I get their emails and I go to the website, I'm just, astounded by the sheer volume of high quality material there. So, obviously, um, uh, Discovery Institute, and for just different aspects, I recommend Luke Barnes. He's got some great popular level stuff. A couple of books that he's co-written with another author. Um, for questions about, particularly design and talking about things like the multiverse, William Lane Craig is a really good resource. He's got a popular YouTube channel, his debates, tons of material on his website. Those are some great starting places.
Okay. And we can also turn to your Substack as well for
Yes.
future writing on these
Yes.
topics
If
and
I'm allowed
others.
to do a little plug for that, yeah, I'm just having a ball writing on my Substack, and so I would love to have people join me there.
Schrodinger's poodle. Okay. We've got it. And that's on Substack. Great. Well, audience, you can catch the full trailer for The Story of Everything and get tickets to see the movie in theaters at thestoryofeverything.film. That's the website for the movie, thestoryofeverything.film. And if you're interested in bringing a group to see it, we have a special website with details on that. If you want to buy out a theater or host a special viewing event, we would love to have you do that. You can go to discovery.org/story to learn more about that particular thing, discovery.org/story. Well, for ID the Future, I'm Andrew McDermott. Thank you very much for your time, Sarah. It's been great.
My pleasure.
Yeah, and audience, go get the trailer and get your tickets, and let's see this movie together and enjoy it. It is a visual feast, as I call it. I have actually seen the whole thing several times, and but I'm excited to get to the theater and see it again. So, for ID the Future, I'm Andrew McDermott. Thanks for joining us.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.